Okay, I hope everyone can hear me. Assalamu alaikum. Please just write in the conversation window so I can understand that everyone is hearing me. Everyone can hear me out. Please just verify so that I know that everyone is hearing me today. Okay, so today I have over here. Let me just. Today I'm going to show you the relays as well, and today this lecture is being recorded, so I have to actually take a lot of things into consideration. The recording, the camera which I have now set up here today, and all that stuff over here. Okay, today our task over here is this, that we are going to have a 12-volt relay designed in the LTM. That is actually a model, a footprint actually we can call it. So just like the footprint of a transistor or anything that you have done up till now. Then we will also be talking about a 5-volt relay, almost same schematic, same thing, but it's a little different from the previous one. And then we will talk about an alphanumeric display model, which dimensions I will give over here, because certainly people don't have it over here. And then that will be an assignment that you will have to make a model of it yourself. And then at the last we are going to discuss projects. Projects are going to be become on first come first serve basis. Sir Bilal will actually tell you about it, that how you are going to be given those projects. Certainly we will make some time available, maybe like today or maybe tomorrow 6 p.m. something time. A link will be given and you will be asked to select your concerned project from over there. The projects will be done on per group basis, the same groups which you have had before, and before the lockdown and all this happened. So, and certainly since the department has actually conveyed us one important notice, that the university is actually going to open approximately at approximately 17th of August for 2017 and 18 session for exams certainly, and for laboratory sessions. So certainly for you as well. So this project, whatever you are going to design, so we have decided that it should be in group basis. So physically you will have to make this one also. So that's why we have shared it with 2 persons, so that the cost of that is also going to be shared between 2 persons. Now out of all those PCBs which we have designed up till now, which of them would be manufactured in the department, or which are you going to solder it? We have not yet decided on it, because we still are not aware that how the university will open and how much time we will have before the end of the semester. So it's still not decided. Anyway, coming on to, we will discuss this projects overall. We will have some extra sessions as well, because the project list is going to be shared with you. I will share that list maybe today or maybe afterwards. So that project has approximately, it says 22 to 23 projects. It's almost the same one last year. Just 2-3 changes I will make hopefully, and then that list will be shared with you. So today what we are going to do, we have the LTM software and we have everything over here. So first of all, I hope everyone can see this screen of mine, and this is actually my mobile. I hope everyone can see this over here. This is actually my camera on my mobile, and I hope over here everyone can see this relay over here. So this, I am holding a 12-volt relay. Now how this is a 12-volt relay, let me just zoom it a little so everyone can have a look what I am actually talking about here. So this is a 12-volt relay, as you can see over here. This is a 12-volt relay. This is a little small lag over there. I hope everyone can see this one. This is approximately 5 ampere DC 12-volt relay. Now this is actually done in a transparent holding. The relay is actually transparent, as you can see. If you can see inside over there, there is a coil over here which is called as DC 12 volts, and this DC 12 volt is actually telling you that this coil is going to work, and when it is going to be energized, this let me just use a pair of forceps for this purpose. So when this coil is going to be energized, this one, so what will happen over here, if I can show you this one, this lever over here, as you can see over here, this is going to be attracted by this relay. So when this is going to be attracted by this coil over there, the contacts are going to change which are at the bottom end. Now for those who are a little not aware of this, maybe some of you will be still aware, this relay over here, as you can see, there are approximately 5 contacts. Certainly 2 will be of the coil, so that you can energize it. This one and this one, they are the 2 ends of the coil. You can verify it by a voltmeter as well, or a multimeter. So you can put just one end of the meter here and one end of the meter here and measure the resistance. So if the resistance is there, certainly something 170, 180 ohms, if I'm not wrong, the resistance of this coil. So this means that this is going to be the 2 ends of the coil. I don't have my meter at present in my view, otherwise I could have shown you this one. Anyway, so these 3 remaining, this one and this one, this one and this one and this one, these are the, okay, sorry, that's actually turned off. If you can see over here, this contact over here, this one and this one, as you can see over here, let me just zoom it over there. So if you're seeing this one is going to be the common point, and when this will get attracted, if you can see this one over here from maybe this side, so when this is going to be attracted over here, this contact over here is going to be attached to the center one. So this means actually that this pin over here, this pin over here is going to connect to this pin over here when you are going to have it energized. I'm again repeating over here. A relay is actually an actuating device by which you can actually turn on anything by remotely or by some other electronic process. Maybe you want to give a laptop a signal, from a laptop you want to give a signal to a bulb or a fan or something. So this relay can actually work in that sense over there, which means when you are going to give 12 volts at this pin and this pin over here, you are going to over here have this contact, which is actually the common point of your relay, with this point which is actually normally open. Now why I'm using this word normally open over here, because this is open when the coil is not energized. When the coil is energized, then this contact and this contact, they will be closed over here. Otherwise they are normally open over here. But when the coil is not energized, this coil or this end and this end, they are actually in contact over there. So how, let me just actually give you a meter contact. I hope everyone can, let me just get my meter over here. Okay, now I just told you, I hope everyone can see this one. I have my meter over here. I hope everyone can have a look over here. No, not that. Okay. Okay, so I hope, so this is my I have placed this one on the buzzer, so you can see I have this 2 contacts. Now the first thing, I want to measure the resistance between those 2 points. I hope everyone can see this, the meter view as well. So when I'm having this one, so this is going to give me, so those who can actually see this one, this has to be in something in ohms. Okay, so this is something you can see over here. This is 0.4 kilo ohms, which means 400 ohms. So the resistance of the coil over here is approximately 400 ohms. So this is the resistance of the coil. You can calculate the current yourself, because this is going to be 12 volts, so certainly you are going to have it. Now when I want to have checked that which is the continuity test, as you have already done before, so let me just place this on this one so everyone can have a look on this one. Okay, so when I will contact this pin, first of all just checking my meter, so I have this one, this is not buzzing, this is buzzing. So this means that these 2 contacts are in contact with each other before, without energizing, and when they will energize, this will beep on. I don't have still at present 12 volts over here. So when I'm going to have a contact, this one is normally closed at present, as you can see over there, because I have placed it opposite. So this is something over here. So this is normally closed, and this is normally open at present. So when you are going to give 12 volts here and here, you are going to get the contact over here. So if you want to supposedly turn a fan on your signal, so if you want to turn a fan on over here, so what you will do, you will just give 12 volts over here, and you will give the fan contact at this point, and you will have the 12 volts, the 220 volt live wire coming over here at this point. So this is a relay over here. Actually, the point over here is this, that this is a relay, and this one is a 5 volts relay. I hope everyone can see this one. Let me just zoom it a little so everyone can have a look. This is a, so I hope everyone can see this or read this one. This is a 5 volt relay. As you can see over here, this is a 5 volt DC 5 volt relay, and DC 5 volts, this is 5 ampere AC 125 volt, which means this relay can only work at 125 volt AC, not at 230 volt AC, because normally in our homes we have that 230 volts over here. So this relay may be not that enough, so you can only use it for something an AC voltage of 125 volts over here. Now this relay which I am showing you at present, it's a little different. It's a little different nomenclature over here. You can see again there are 1, 2, 3, 4, 5 pins. Now these 5 pins over here are certainly, 2 are going to be coils, 1 is going to be the common, other 2 are going to be normally open and normally closed. We can verify this one with the meter as well, but here I am not going to talk about this one first. I am going to talk about this 12 volt relay first over here, because we want to make it this contact over here. Now first of all, whenever you have any item and you want to make a footprint of it, the first and foremost thing is this, that you need to know the dimensions of this one, because this relay, maybe it's the PCB footprint can be found out, maybe you can find it from internet, but sometimes the item is not there, so you have to make the footprint. The first thing which you want to actually do is this, that you want to find out the practical physical parameters of this one. So what I'm going to happen over here, please note it down, I don't have my pen or pencil over here. So I'm just trying to find out the outer boundary of this one. So when I want to find out the outer boundary, I'm going to measure in millimeters again. So this is something 21 mm approximately. Better if I can use a vernier caliper for this purpose, but actually I think so my vernier caliper is not working at present. Actually I have don't have the cell actually working, so I will have to use this steel ruler over here. So this is normally approximately 21 mm. This is the height over there, and if I want to find out the width of this one, so this is approximately, if I'm not wrong, this is approximately 16. So 21 into 16 is actually my outer boundary over there. Now if I want to find out the pins over there, now these pins are very, very important. Now how I'm going to actually verify this one? Now one thing very important, whenever you are going to place the pads over there on the PCB file or the footprint file, you will require approximately the center to center distance. This is very important. So from the center of this pin to the center of this pin, you need to find out. And certainly when I know this distance, this is 16 mm. So if I will know the distance between these two pins, supposedly these two pins, they have approximately, now I don't know how many of you can actually see this one, but if you have a very good vernier caliper, this one is a little easy. But this is approximately, if I'm not wrong, 12 mm approximately, 12 or 12.5 mm. So 12 mm can still work over here. So the distance between this pin and this pin, this is 12 mm over there. Now then certainly between these two pins, it's also going to be 12 mm. But when I want to find out the distance between these two, this is approximately, if I'm not wrong, 11, 12, and this is approximately still the same, I guess 12.5 or 12 mm over there. Now before I proceed further and make the other dimensions over there, I will just click on to again the LTM software over here. Meanwhile, up till now, anyone has any questions regarding this, whatever we have done just now? Please, I know the video is lagging beta. Yes, video is lagging. Actually, this is being done by my camera and I'm streaming that result on the Okay, so no, there is no video actually. Why there is no? Yes, video is lagging better. Don't worry on that part. Don't worry. I will share the snapshots as well of this whole device. Okay, don't worry on that one. Okay. But for those who are still lagging behind, let me just show you what I am actually talking about. Uh, Let me just show you. This is a 12-volt relay. I hope everyone can see this. What I am actually talking about. Okay. So something, a 12-volt relay. What I have in front of me is something like this. This is a 12-volt relay, as you can see. I hope everyone can see the shared screen over here. This is the 12-volt relay which I am actually holding in my hand. Okay, this is the same 12-volt relay. So for those who are having a video lag over there, don't worry on that one. I have made that video. It's being recorded at present, so certainly you will have that video. And the 5-volt relay which I have in my hand, other one which I showed you just now, that's approximately the same shape like this one. This is actually the same shape. So this is a 12-volt relay, and if I'm interested in the footprint, now as I told you, sometimes you can find out the footprint also from the internet. So I am having something like this. Now as you can see over here, this is the same almost shape over there, a little bit different over there. You can see this distance we just measured on over here was 12 approximately, and I told you this was 12.5, and you can see this distance is 2 mm. So sometimes on the internet you can find out the footprint, but supposingly the footprint you don't have it. Now over here you can see the footprint is also shown where my mouse is actually hovering at present. And certainly if I just scroll down a little, maybe I can find out some other relays as well, some other different relays over here. This is a single pole relay. Remember, this is a single pole relay. And over here this is actually something. Yes, this is the same dimension which I'm actually talking about. So I can use these dimensions. This is totally up to me, whatever I want to use over here. So I will be using this dimension. Otherwise you have to know these dimensions yourself over here, that how you are actually going to use it. You can measure it by your vernier caliper or by your ruler. Otherwise you can find out these dimensions yourself on the internet also. If you have something having common, then certainly. But otherwise if you have something a little different, maybe let me just show you a little. Maybe if you have a this 7-segment display, something over here, let me just show you what I'm actually talking about. Okay, so this is that 7-segment over here. You can see this is an alphanumeric display. I hope everyone can see this one. This is actually 1, 2, 3, 4, 5, 6. These are 6 alphanumeric over here. Now you have seen 7 segments up till now. You have used 7 segments in the first 2 experiments. This is an alphanumeric. Now this is not just one alphanumeric, this is 6 digits alphanumeric over here. As you can see, I'm holding this one, and to make this footprint it's a little difficult, and you can see this footprint is having so much pins at the back. As you can see, these are approximately 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 22 pins are there. So these 22 pins. Now even if you will search this number which I am pointing out at present, you won't find the footprint easily. Even if you can find it out, then maybe still you will have to make that footprint yourself, because you will only get the dimensions. So sometimes you have to make the footprint yourself, sometimes you will get a footprint from the LTM library, unless and until. So for relays, sometimes you will have to make it yourself over here, and for other items maybe you have in the LTM software. Now switching on to any questions, Ji beta? Any questions from the class? If over here roll number 22, whatever you wrote, I just read it. Yes, the video has a lagging. Don't worry on that part, because actually I'm streaming it from my mobile camera, and then from the mobile camera I'm streaming it in my laptop, and then from the laptop it's actually being streamed to you. This lecture is being recorded. I have taken care that this is lecture being recorded. This is being recorded. Don't worry on that part. Okay. Okay, so let's just take those dimensions which I just showed you. This is the same dimensions over here, and I hope so we did that dimension. Let me just verify it out. The dimensions were approximately, this was 22 and this one was approximately 16. So 22 cross 16 was it. Now when you are going to work in LTM, now one thing very important, first of all you will go on file, and you will go in new, and you will go over here in the library, and here you can find out that you want to make actually a new PCB library. Now this PCB library, when you will click it, this will straight away take to your totally new interface over here. Now the problem over here personally, which I feel practically over here, is this, that in this PCB library, all the dimensions, they have to be done in the mills. So what I do over here, normally you can do this also, or maybe you can do the normal natural way. You first of all make a small new PCB library. Now why I'm doing this, I will just tell you a little now. Just make a new PCB file, change the design units over here to your metric, and change the grid lines over here. So, and now I told you initially when we started the software that this is a step X. This means that how carefully, minutely you can use or share your mouse over here, that you can change the object orientation. Now when you do it very small step, that is 0.025 mm, you are actually having a very good sensitivity of your mouse, then you can use it. Otherwise, if you are not good at it, then you can use something 0.10, 0.25 or 0.5. But since I am designing a footprint, so I am actually trying to make it 0.025. I will click apply, and I will click OK, and I will just click again apply and OK. So now I have this black area. Now what I will do, I will draw the footprint on this PCB, and I will take it in this PCB library over here, and then I will attribute some properties over here, and that will be actually a PCB library done. Okay, so now over here, the first thing first, I want to actually make an outer part of this relay. This was 22 into 16. Now how you are going to make this one? Now this is very important over here. So over here, I will first of all use maybe a bottom layer just for now. You can use the top over relay over here as well, but it's totally up to you. Anyway, I will just use the top relay. I will use this track, and now this by default it is giving me a very small thickness of the line, and which is good. Why? Because the more thicker, you will have more errors over there. So what I will do, I will just make a line and just stop it. Now what I will do over here, I will zoom this one. Now I know this is the line. I will double click this line. Now as you can see over there, the Y parameters of over here is 69.775 mm. Here it's also, because the Y dimension is not changing, only the X dimension is changing because this is the horizontal line. So this is 68.525 just for now, because I need a 22 mm horizontal line. This is a 22 mm horizontal line. So just for now I will make it 68, and when I will add 68 plus 22, this will be 90. So this means this will be a 90 mm line. So this is my 90 mm line over here. Now since this has not to be of the bottom layer, so I will double click it again, and I will make it a top overlay. Let me just find out. Yes, this is the top overlay. So I have this 22 mm line over here. I will just zoom out a little. Now since this is going to be a rectangle, and this rectangle is going to be of 22 mm across 16, so I will need two of these ones. So I have just made two of these lines over here. Okay. Now the next line I require is of 16 mm. So I will again go to interactively route connections, the same track or whatever you want to call it. And now this time I will make just a vertical line. Now when I will double click this line, again the Y axis will be changing, X axis will remain the same. So now what I will do, since I require 22 cross 16 rectangle, so what I will do over here, I will make this 73, and here with this one, because 73 plus 16, this is going to be 89. So now what I have done, and I will just change this to sorry, top overlay. Now I will just make a double of this one over here. So now the outer boundary of the layer of the relay footprint, I have made it. Now I have to join them. This is very important point over here, because when joining, you are not going to change. Now how I'm going to do this one, see this one, either you can drag it, okay, or one thing very important, whenever you are going to cut it. This is very important, please. However, first of all, select this, select that line, use Control X and at that point wherever you are cutting it, just select it. Now whenever you are going to paste it, it is at your fingertips now, at your mouse now. So now I can place it here so that it is exactly, not still it's not that very good. It's a little problematic. Just what zoom it over there. Yes, now this is done. So this is now that 22 cross 16, and here I am going to again do this one, and again I will zoom it. Now this is very important, please zoom in, because whenever you are going to zoom in, you are going to have this 22 cross 16, and here again I am going to have this I hope everyone has an idea how to zoom in, because every time you can't go to some control keys, you can just press control and use your mouse scroll. This will give you the option. Now you can see the edges. This one is a little below. Okay, that's one, that was a little wrong. Let me just do it again. Okay, still it's not very perfect. Still not perfect. Okay, this one is. Okay, so this one is 22 cross 16. Now if you want to verify this out also, let me just confirm this one. This is correct. Okay. Okay, so if you want to verify it out, this is actually 22 cross 16. You can use the measurement tab over there. Now one thing very important when you are measuring this one, oh, not very good, sorry. This one, actually I have changed the mouse sensitivity, that's why it's actually hovering a lot. Okay, so exactly at the center. So this is 22 mm. I hope everyone can see this. And this one should be 16 mm. Okay, this one is a little less. So this means I will have to actually okay, now I have it. So this is 22 cross 16 mm. Okay, so I hope. Any questions up till now, Ji? Please ask me any questions up till now. 22 cross 16. Ji beta, don't worry on the project. Have your questions for the project same over there, so that you can actually yes, Bilal, please answer some questions which are done over here. Okay, I have this 22 cross 16 outer mark made. Now I will now go to the document which I have just taken from the Google. As you can see, I have two pads here which is of 12 mm. Now before I can put a 12 mm these two pads, what I require from this edge 5.75 mm, 5.75 mm, and I will put a straight line, and on that line I have to put these two tracks over there. Now this will be just a fictitious line at present. I will rub this off over there. Now so I will go back, and now this time I will make a small dimension over here. Let me just make a small dimension over here. I hope everyone can have a look on this one. This is not a very okay. So this one I require 5.75 if I'm not wrong. Okay, this is still not. Let me just this is okay, the same way as you did for the line. This is going to be 625, and this is 75 mm, and 75 plus, let me just verify it again over here, 5.75. So 75 plus 5.75, this is going to be 81.75. So this will automatically become a line of this much length. Oh, sorry, गलत कर दिया, sorry, this is 68, sorry, this is 68 plus 5, this will be 73.75, sorry about that. Okay, now again I will just cut this one and I will just paste this one here. Now again I will paste one here. Now what is the advantage of this one? I am just going to place a fictitious line from this point and this one here, okay, and this is just a fictitious line. I'm just trying to make a footprint, okay. I will just save my work just for now so that I don't do any have any outage issues. This is a PCB, let me just save it by some PCB footprint file. This is not actually the library, I'm just doing the work in the PCB doc file. Okay, so what I have done, placed a fictitious line over here. I will just delete this line afterwards. Then I have a 12 mm. Now this one is very important. I have a 12 mm distance between them. So what I want actually, I have this length over here equal to 16 mm. So what is the remaining? That is 4 mm. So this means that the center of this pad to this one, it has to be 2 mm, and from this side to the center of this pad, it has to be 2 mm. So this means that this time I will make another, let me just make another dimension, and this time it will be of 2 mm. So this will be 2 mm. I will just again verify it. This is very important. So this is going to be 94 and this is going to be 92, and just to verify that this is 76.45. so this is my 2 mm line. Now I will just select it, do a cut over here on this point, and now I will zoom it. Please, one thing very important, whenever you are working on this footprint one, have a habit of actually zooming in, and then this is actually giving me some problem. Let me just take this out over here. Okay, so this one, and now you can see the problem which I am getting at present is this, that the mouse is giving me a lot of sensitivity. Actually my hand is a little bit, this is not a good one actually. Let me just take this out. Okay, so you can see now actually when there are too many lines, this is difficult over here. So this one is exactly a 12. So what this means, that at this point I am going to place the pad. So what I will do, I will take this pad from here and straight away put at the center. You can see this one. Okay, why did not place this place? So the first pad at 5.75 mm from this side and 2 mm place. No issues over. Similarly, this time I will again take this track and I will just maybe rub this one, and now this time on the lower side, let me just rub again this track over here. This one is not required at present, so I will just cut this again and place it. Now you can see zooming in is very important, and so you can place it very carefully, because if the lines are not placed accurately, so you are going to have a problem. So what I will do, I will just select this, and you can see when I have selected it, and if I will move it, this is exactly at the center. So now what I have done, I have placed the two pads over here, which means I have placed these two pads over here like this one. Okay, so I have placed these two pads over here. Now the next thing is this, I want a 12.2 mm. I want a 12.2 mm from this two, and then again a vertical line, certainly, and again those two pads again with the same distance of those one. So that's why I have not deleted these dimensions of 2 mm and all this stuff over here. Now we will delete these fictitious lines afterwards, because I still need this line over here. Why I require this line? Because over here, if I can just go back, I require a 12.2 mm distance between the other one. So when I will require a 12.2 mm, I will use this one, and this one is 12.2 mm, Now this is the little. Now don't verify on your hand, because every time I will just click it, you can see this is 70.75 and this is 70.7. So certainly this means there is some error every time whenever you are mouse clicking. You cannot rely. Please rely on these values which you are every time getting over there. I require 12.2 actually, so this is 63, and here I will make it 75.2 because the distance was 12.2 mm. So this is 75.2. I will click OK. Now this has little dragged over there, so don't worry on that part. You can just do it after just now. So I will, you can see when I'm moving it, the mouse automatically has it. Now just to make that line a little better, so what I will do, I will place another one over here, and here again I will place a fictitious line, and this will be, you can see I'm just passing it straight over here and it is just crossing that point. So no need of this bended one over here. So this one again, a pad, let me just select it so the pad can be placed easily. Okay, so now I'm going to place the pad here. Okay, one thing, sorry, I missed one thing. I have to place the 2 mm line also. This is very important, so please don't miss that 2 mm line. This is very important. This is 12.2 mm. We don't need it. I'm just going to drag it there now. So the 2 mm line, I will just cut it or copy it. This is totally up to you, and since I require this one, so I will again, so this is my 2 mm line, and now since this is selected, now I can take a pad and this is placed. Okay, so I will just take another 2 mm, just copy this one, so this is copied, and okay, this one is the direction is opposite, don't worry on that part, and I will just place it. Okay, this one is a little draggy. Okay, sometimes the software, actually I will just make it a little above, and now this is going to work over here. So you can see just the center of this track, and now here, and now I can place the pad easily. Please always select it, so when you are dragging the pad, it's exactly at the center. So now you can see I have placed those 4 pads. Now the remaining 1 pad is here, which I have to place. Now here at this point, it's a little messy around. I will just take these dimensions out from here because I don't require them. This one is this one. Okay, now I will just save it. Any questions up till now, Ji? Any questions up till now? Gigi, dimensions are only for the measurement, they are not for the design. We will put the names as well. I will tell you, don't worry. I will make these names just now when I will copy this from this file, and I will make them on the other one. So this is the boundary on the top layer and all that stuff over there. Okay, now the last pad, which is actually the 12-volt relay, if I go back on the same design we have just done, this is at a distance of 2 mm from this line, and certainly it's at the center. So what I need to now find out, first of all, I need to make a center line, and I need to find out this one, because if I take the dimensions and if I measure these dimensions here, this is approximately 12.1 mm. Now why this is 12.1 mm? Because this is a counter check I am doing it, so maybe I have done some error over here. It is still 12.1 mm. Was this 12.1 mm? Let me just verify it out. This was 12 mm. Okay, this is 12 mm or 12.1. We will just see afterwards. Anyway, so this is 12 mm. I need to have exactly at the center a horizontal line drawn over here. I will have to make a horizontal line drawn over here. So what I will do here, whatever dimension I have over here, I will double click this one. Actually this is not in a straight line, that's why actually this is not exact. 6565, and for Y I have 82, and here I will have 82 minus 6.05, so this will be 75.95. Correct me if I'm wrong. This is 76 to 6.05. This is exactly true. So please verify me out. Bilal, you can verify me out. Okay, so I'm just putting this 6.05. This has to be 12, so that was 6, but by dimension is coming out 12.1, maybe so because of some error. So don't do that one, you can correct it yourself. Now what I have done, I have made 6.05 line here, 6.05 line here. Now from this point I can make a straight line. I actually don't require this one, but still I'm extending this line over here to this point. And now the next thing I require is a 2 mm line from here. So what I will do, I have already the 2 mm dimension, so no need of recreating it. It's actually in vertical direction. If I press spacebar, this is already changed to the horizontal. So what I will do now, I will cut it from here and I will paste it again here at this particular point. So you can see I've put it here, and now this point is the pad point. So this is the pad point over here. So now you can see I have placed the pads over here. So all the pads are placed, assuming this is 12. You can correct it yourself afterwards. I'm not going to again verify this one. Now I can take this vertical lines or the factitious lines which I have just drawn over here. Okay, ji? So now you have the footprint available, and this is exactly just for your something. Let me just show on again the camera over here. I hope everyone can have a look on this one. Okay, so okay, why the camera is not actually working on my side. Okay, I have this camera over here, and the same footprint I have over here in my hand, and you can see the same 5 pins, and what I have done, the same 5 pins. Now one thing very important over here, this is very important. I am holding this pin over here, or the 12-volt relay, in my hand, and the pins are facing towards me. Okay, but when I am going to actually place this on the PCB, this is going to be something like this. This is very important. So when this is going to be placed straight away, so this pin is the common, as I told you. This pin is the normally closed, this one is the normally open, and these two are the coil pins. So what I'm going to do now, I'm going to go again on the software, copy this over here. One thing very important, copy this one over here, go on your PCB library, now paste it. Now when you will paste it, okay, paste it anywhere, but this is, now when you have pasted it, this is very important. First thing first, whatever pad you want to call it, because whenever you are going to use a footprint, you require that what is that pin doing. So here, first thing first, because I have told you up till now that you should use a 2 mm size over there. Now for those who have still no idea, that whenever I am using the mm to mils, I am actually using this over here, because 2 mm size is enough, and 2 mm is approximately 78.74. So what I will do over here, I will change it to approximately 80 mils over here. In fact, traditionally it should be more than that. Why? Because these pins of the relays, they are a little, sorry, so these pins are a little thick. They are not just like the 7-segment pins or something like this. So what I will do over here, instead of making them 80, just for, because when you are going to drill them, they are going to be a little large, so I'm going to make them 90. Similarly, I am going to make them 90 over here, because these are relay pins, because they have to handle a lot amount of current. Maybe there is a fan working, or maybe there is something else. So I'm doing this one. I can do this one by the filter command as well, but it's totally up to you, because there are just like 5 pads over there. I don't need to actually do something very sorry. This one is 90. This one is also, sorry, 90 mm, and this one is also 90 mm. Now I've still not named anything, because when you are going to use this footprint is going to be on the common. So this one and this one, they are coil sides. So I can call this one designator over here, instead of 3 number, I can call it coil negative. There is no harm. You can call it coil positive, coil negative. The relay will still work, because it's going to work as an electromagnet. So it's just going to be having a coil negative here, and this is going to be used as a coil positive. So now this is coil positive and coil negative. Now since this term, this one is the common point. So when this is the common, I can write it common over here, or you can just write C over there. That can also work, because normally smaller names are better, but still anyway common can be okay. And then when you are holding this over here, I hope everyone can see this one. When I am going to use this PCB, these pins are at the bottom, and as I just told you, when I was holding this one was the common pin, this one was the normally closed pin. So when I'm going to turn this round, the common closed pin comes here. So this means, so when I will go back over here, this is the normally closed. Now here I will write just NC, and here I will write NO, which means this is normally open. Normally means without energization, what happens. So I have now marked everything like this one. Now you want to name them as well, okay? Because they are the pad names. You want to name them, because sometimes whenever you have the footprint, you want to have some name. So here you can write down some text over here as well. Place string, place it over here, okay? And double click this one, call it NC, because this is NC actually, and use it top overlay. So now this is NC. I will just copy this one and place it here for NO. Double click again, and this is NO over here, which is normally open, and again I will place it over here for the common one. I can call it for the common one. It's totally up to you. So no need to, you can write down over here, but it is already understood that these 2 pins are actually for the coil over there, so that you are going to energize it. Now one last thing which you need to do, you will go on your tools, you will go on your component properties. Here you have to write down, very important, the name of this one. This is 12-volt relay. Okay, this is a 12-volt relay, and here I am just going to write it down, because this is a little different from, I have already made it, so I am just giving a different name over here, because I have already have the 12-volt relay in my library. I made it before as well. So this one over there. The next thing over here, I'm just written 2019, because this is the 2019 session going on. Description, you can write anything. Okay, it's totally up to you. The same description you have been finding out in every footprint. What is lead spacing, what is the pin spacing, what is the body weights, and all that. So all that description which you are going to see. So this is, I'm just going to write down, this is a 12-volt relay footprint over here, just wrong. Now next thing, height, very important. Up till now we have not measured the height of the device. This is very important, because that will actually make the 3D symbol of this CAD over here. So when I'm going to make it, this is going to call it over here, this is approximately, if I'm not wrong, I'm measuring it actually with my camera viewfinder. I hope everyone can see this one. I'm just using this one. So this is approximately 23 mm. So when we were having 23 mm, so I can just go back on my software, and since this is in mils, I already told you this is 23 mm, and this is 905.5. So I can just call it approximately 906, just to be on the safe side, and I can just click OK. Okay, now this was the last thing. If I will zoom it, you can see there is written coil plus, coil negative, there is written common, there is NO, there is NC. Now whenever you are going to make this library, the first thing first, you have to know from where you are actually going to hold this. So what I will go on the edit command, set reference, Okay, this is very important, and select center. Now what I have done, I have selected the center over here. So whenever this command or whenever this library is going to be hold off in my whatever PCB file, this will be holded off from here. Now here almost all thing is done, just one thing is remaining which I will tell you afterwards. So now here I will save this. This is still unsaved, so I will just save this. And now when this will ask me to save, I will go on my, actually I have saved them somewhere else, but let me just add it over here in your, over here. This is 12 volt. Now the name has to be very important because this is very important. I'm just going to call it 12 volt relay 2019. The extension is PCB library, and I will click save. Okay ji? Now this is saved. So this has gone in the somewhere in my directory or whatever device over there. Now if I just open some of my any PCB, let me just, and I want to import this just like I have to add it. Now this is the same PCB, the same footprint I just showed you. So you can see I have just made this footprint also. Let me just show you what I'm actually referring to. This is the same footprint. You can see this is 1 2 3 4 5 6, and here this is the same 1 2 3 4 5 6. You can see this is the same footprint I have used over here. This footprint was made by me. I made this footprint, and this is exactly the same of like this what I am holding in my hand at present over here. Okay, so I hope everyone can make, I will show you the dimensions afterwards when we give you the assignment today. Okay, now I want to add this in the library. I will go again on component. This will take some time because I have a larger database. Okay, this is the footprint. Now I want to install a new one. This is actually the 4-digit 7-segment display which I just showed you. No, actually this is the other one. I want to add a new one. So I will go to install, and here I will go on the 2019, and here this is the 12 volt relay. When I will click OK, now this is there. This is available in some of my F drive and all that stuff. And when I will click this one, okay, so I have now it over here. So you can see the description. This is the 12 volt relay footprint, and as soon as I will click OK, I have this on my cursor. So now you can now use this 12 volt relay in your footprint. This is totally up to you what name you want to use it. Okay, any questions up till here? G, any questions up till here? Please write down in the Jay, any question? जी बेटा, classes are going online. छुट्टियों वगैरह की बात तो खैर वो it's going to be different. We are already working online, so everything is online. So I have just made the footprint of a 12 volt relay in front of you, and okay, let's do one thing. I guess no one is asking me a question at present. I will give you a maybe a 15-minute break at present, but in this 15-minute break, no beta, Monday is not off. From Monday again the classes are going to because this is online stuff happening. Now what you have to do, you have to make a 5 volt relay footprint, and let me just find out for you the 5 volt relay because I don't need to give it over here. This is the 5 volt relay footprint. Let me just find out the dimensions actually what I am actually referring to. Okay. Let me just give you one important. You will see this is the same 12.2 and all that stuff we have just done. Okay, now okay, let me just this is deco. Okay, sorry, 5 volt deco relay. Any questions? Meanwhile, you can write down in the conversation window if you have any questions over here. I'm trying to actually find out the dimensions over there so that you can actually just make a small one in the class, and I will just compare one over there. Whoever makes it, so certainly I will give some advantage over here. So you can take it as some classwork over here, those who have understood this whole thing, which we have done just now. Okay, this is very good. Uh, this is a single pole dual throw. Okay. Okay. Let's just do this thing. Okay, ji. You have the outer dimensions over here. Okay. This is the whole dimension which I have just given. Take maybe like even 30 minutes over here, and what you have to do, whoever does it first, or the first three students, whoever do it, they are going to be given, this is the image. I'm posting it over here at present in the okay, this is posted over here. This is the dimensions figure I have posted in the okay. The outer dimensions are approximately 10 cross this is, let me just find it out, 10 cross 20 you can call it. The outer dimensions are 10 cross 20 ठीक है जी. Make a footprint over here. This is also a single pole relay, but different contacts over there. These two over here, as you can see over here, these two are the relay coils. This is the common point, and these two are the normally open or normally closed contact. Since I don't have the relay at present physically, so that's why I can't actually show you, but please do this one just now. I have given you the dimensions. Share with me in 30 minutes. The first three students who will make the footprint just now will be given an absolute marks increase in their total lab marks, whatever you have done. Ji beta, your time starts now. It's approximately 2:10. Take a 30 minutes break from now on. This work is not more than like 20 minutes. So try to do this one. I have shared in the conversation window a diagram or the dimensions of the relay over here, and in this relay the outer dimensions are 10 cross 20 over here. Take a 30 minutes break from now on. This is 2:10. We will be joining back at 2:40, and whoever are the first three students who can make this footprint, you have to email me, or maybe Sir Bilal can take them one. So whoever is going to make this footprint just now, because you have seen this one just now, will be given a credit. Okay? So 1.3 beta, 1.3 so that is just a hole. Don't worry on that one. That is 1.3 is the hole size actually. Pad size usse bada hoga. 1.3 is the actually the pin size over there. Rest of all the dimensions are in Okay, ji? So whoever is present, I can just see there are approximately 112 students in the class at present. So I hope everyone can attempt it. Everyone has the first three students who can do this just now. You have to share with me the footprint file, the PCB library file with Sir Bilal. Sir Bilal will share with me afterwards. He has given it a look. So you have 30 minutes from now on. 2:10 is the time at present, and at 2:40 we will resume back over here on the same time. Don't go from here, just do your work, and in 30 minutes we will have a look at what you have done. Okay? The first three students will be given an absolute marks increase in their whole lab, whoever have done it. Don't worry on that part. And if you have been one of those who have copied something or something like this, your marks can be erased. Your last work can be erased. Your negative impact can be erased. So just attempt it. I've given you the footprint, but you have to be fast. The first three students are going to get it. The first three students have to get it. Beta Vakasali, the question here is this: I have given this footprint over here in the conversation window. You have to make the footprint of this relay. This is again a relay. Two coils on the extreme left are the coils, two pins over here. The remaining three are the pins of the normally open, normally closed, and the common points. And then the outer dimensions are approximately 20 mm cross 10 mm. So I hope everyone can see this one. The outer dimensions are 20 mm cross 10 mm, and you have to do this. The first three students who will mail or whoever does it are going to be given the credit. We will just decide the credit. Don't worry, it will be absolute, and I have just given you, whoever has done those copying and all that stuff before, you can have that deleted from your record if you can do this in the next 30 minutes from now on. Okay, I'm just closing the recording at present, so I will resume. Okay, so I hope everyone has done it over here. So Bilal will be just sharing the link with me just now, so I can have a look at the assignments that you have done. Meanwhile, when this link is being given, I am just going to share something with you, the assignment part over here. And okay, so okay, the link is there. Okay. Okay, meanwhile that link is being open and it's being done. What I'm actually asking you this week is this: if you have seen an alphanumeric display. What is an alphanumeric display? Just like a 7 segment, an alphanumeric display is something in which instead of just 7 segments, you have like 16 or 18 segments. Over here, the one which you are seeing in the picture at present, I will share these two pictures in the conversation window just now. I have it physically over here in my hand also. This one I just taken the picture just now, and this is the 16 segment alphanumeric, and you can see easily from here that 16 segments can be used to make A, B, C, Y, X, anything alphabetic you can actually write down over here. Now the assignment is this, that this is going to be either a common anode or common cathode. Now you are all familiar that what is a common anode and common cathode. Now the first task is this, that since I have physically these ones over here, and we can have the name also, as you can see over here, the picture I have taken this one over here like this. You can see the company name is LED Tech, and the model number is LA1221-21B over here. Okay, this one is the 7 segment over here with me, oh sorry, the alphanumeric segment, 16 segment over there with some dot also available over here. Now I will share the dimensions of this one later on, but if any one of you can search on Google, the model number is there. LED Tech is a very big company famous for alphanumeric displays or LED lightings and all that stuff. So if you can find out this LA1221-21B, find out the data sheet of this one. Now this is a little obsolete. By obsolete, whenever you will find out the word obsolete in the electronics catalog, this means that the manufacturer is not yet making this now more. So this means that it's difficult to find out the data sheet. Meanwhile, for those who are over here finding out the just wait, sorry, this one is the LED Tech website over here. I have just found out the LED Tech website also, but I cannot find the LED Tech version over here. The reason behind it is that let me just paste the link over here. Actually, I'm trying to paste the link over here. The link is actually let me just paste the link. Okay, this is the link, and I'm just copying that link over here. Okay, So if any one of you can find out, because this is not available in that link, this link over here, as you can see, this is the website of LED Tech. It's a UK based company, also based in China. So I have the alphanumeric, but it does not have the exact alphanumeric which I have physically at present over there. I will upload it maybe by today evening or by tomorrow. What you have to do, since the dimensions will be something the similar like this, the one which I am holding in my hand at present, it has a digit size of approximately 1.251. Now supposingly if you have something 1.0 of single alphanumeric, you can see this is written LA 2521-21B. The one which you have over here, which I am showing you at present, it is LA1221-21B. So this is a little different over there, but anyway, if you open any one of these, let's just open one of these, and the data sheet is available in front of you. You can see there are different colors. You have green, yellow, orange and red. Sometimes you have always using the red one. So if you open the data sheet over there, the link has been shared with the conversation window. You can scroll through this one. Now you can see the data sheet. Now in this data sheet you can see you have the pins for the common anode also and the common cathode also. The first one over here where my mouse is hovering at present, this is the common anode, because you can see from pin number 6 or 18 you are going to have the current flowing down, and from pin number 6 or 18 here the current is sinking down. So this is actually the common cathode one. Now which one you have to use, the common anode or common cathode one, that depends upon the model number which I have just shared you. You have to find out a data sheet. If you can't find it out, I will share the data sheet of this one by evening this time today, and we will give time for this assignment since this is Eid also in this holidays over there. So maybe the due date of this assignment will not be on Tuesday next. We will extend it by 1 or 2 days more, because in the next week we will have some 2 sessions for the projects also. So this is very important that this assignment can be done, because there is going to be some projects also related to alphanumeric. So this is the alphanumeric display which we have to use. This is the same thing which I am holding at present over here in my hand. The dimensions are a little different over there. You can see over here that length of the digit over here which I am showing you at present, 25.4 mm, and this is actually 1 inch. And if you can see over here on the top over there, this was written as 1 inch alphanumeric display, but the one which I am holding at present, this is 1.2 inches. So actually I want to actually ask you to make this physical one, because I have a lot of these alphanumeric displays with me at present, and maybe if we can, the university can open and we can make this PCB, so you don't need to actually buy this alphanumeric display. So I have those displays with me, I guess 8 or 9 of them, so we can just have those. You don't need to buy them from the hall road, you just need to make the PCB and all that stuff. So you can see over here the common anode or common cathode. Now what is the assignment over here? I will share the data sheet afterwards. What you have to do over here, you have to place, for example, I will show you one alphanumeric display over here. This is also an alphanumeric display. This is a little different from yours one, this one over here. As you can see over here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And these 15 ones are actually the 7 alphanumeric displays over here. And in this alphanumeric displays over here, as you can see, you have the 15 digits of the alphanumeric. I will just on the camera so that everyone can have a look what I am actually trying to show you. And this PCB which you are seeing at present is actually this one. I will just open the camera, don't worry, on this one over here. Okay, I hope everyone can have a look on this one. Let me just open the camera over here. This is a little difficult being an online, but still I'm trying my utmost best so that everyone can have a look. Okay, this is the same alphanumeric display as you can see over here. This one is the same alphanumeric display. You can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. These are 14 alphanumeric displays over here. As you can see, it's quite long over here. Now, I'm not asking you to make actually a 14 digit one. You are going to make only alphanumeric of just like 5 or 6, or if your own name has only like maybe you are having a 4-digit letter of your own name. Supposedly someone is Abid or something, one is anyone simple name, so you have to only make 4 or 5 of them alphanumerics, and you have to combine them together. And since in the data sheet you are given this pin number 2, pin number 22, pin number 21, pin number 16 and all this stuff, you will combine them, because what is pin number 2, pin number 2 is A1, pin number 22 is A2, pin number 21 is B, pin number 16 is C, and so on. Now what are these A, B's and C's over there, for those who are still wondering that what is this over here, alphanumeric segment. Let me just show you. This is the alpha numeric segment over here. As you can see over here, I have this one is as the A1, A2 and all this stuff over here. As you can see over here, this is A1, this is A2, this is B, this is C, this is D1, D2, this is E, this is F, and then there is G1, there is G2, and then you have the HIJ, KLM. So you can see using any of these, I'm just now posting this one in the conversation window for those who want to actually have the, yes, the number of alphanumeric segments or alphanumeric digits depends upon your name. Ego, you are not going to use something like your name. Please use your real name, otherwise you will just have 3 names in your 3 letters in your name. So you have to use, someone is having a big name, just the first one name, not the last name, don't need of any of the last name. So if anyone name is Abdullah, yes, certainly then you will have to use A, B, D, U, L, L, A, H over there, then you will have require more. If you have a very small name, then you will have to it. So everyone is going to have a different one, certainly. So 3, 4, 5, 6, 7, depending upon whatever that one over there. So what you have to do in the assignment, I will share the data sheet with you. Meanwhile, if you can find out, I have given you the pictures as well. Let me share you the pictures as well, the model number. So these model numbers are there, and I'm sharing these pictures over here. Don't worry, Hassan Mohyuddin, you only have to make it HASAN. Don't worry, don't need to actually make it for Hassan Mohyuddin. You can just make it, I don't know it is single S or double S, you can confirm it yourself. You just have to write HASAN Mohyuddin over there. If anyone has, certainly Abdullah Sabur, you will be on different scale because your name is quite large, A, B, D, U, L, L, A, H. Now you are going to make something 8 or 9. So you have to first of all make a footprint of this one, place whatever the number of your digits you are requiring over here, place them over here on the PCB. Again, the same nomenclature, you have to use SMD resistors, and SMD capacitors and all that stuff, same over here. And the one thing very important over here, you only have to connect your data sheet, whatever data sheet you have opened there in front of you, you have to connect each of these A1, A2, B, C, D1, D2, E, F, and up till this whatever point, whatever data sheet is there, you will have to make them connect with a ULN 2803. Again, I'm repeating, you will have to connect A1, A2, BC, D1, D2, EF, G1, G2 and all this one to a ULN 2803. So all of this A1, A2, B, C and all these segments are going to be combined together. So if anyone has like a 4-digit, 4-letter word, you are making it, so all A1s of all the 4 digits are going to be combined together, and you are going to put it inside the ULN 2803 IC. Similarly for A2, similarly for B, similarly for C, similarly for D1, similarly for D2 and so on. So if you see over here, there are 16 segments over here. No need to work on the DP part. You can leave that DP part out of this PCB. So you will require two ULN 2803s in this PCB. And for the pin number 6 and pin number 18, now if you have, listen this very carefully, if you have 4 digits in your number or your PCB, or 4 alphabets actually, sorry about this, I'm mingling this stuff every time. So if you will have a 4 digit or 4 alphabet PCB, you have to make 4 common drivers over here. By drivers I mean the same driver which you have done previously in your RGB or your yellow dot matrix. Okay, I'm opening this RGB dot matrix data sheet over here in front of you, that one you have done. I'm not giving you a data sheet over here this time, or I'm not going to give you the circuit diagram. You have done it repeatedly. The power supply will remain the very same. The ULN ICs are just 2 of them used over there if you are using a common anode one, and this is a common anode one. And then you have a 2SA684, and since this is SMD, you will be using it BC869 over here, the same SMD one over there. And then you have this 2 and 3904. In SMD you will be using 1A. So if you have 4 digits supposedly, or 4 alphabets over there, you will be using 4 of them, and from this pin of the collector of 2SA684, or in SMD it will be something as BC869, this will be connected to which pin? This will be connected to pin number 6 and 18 of the first alphabet. And then a similar circuit connected with the second alphabet, pin number 6 and 18. Then pin number same driver over here connected with the third alphabet, pin number 6 and 18, and so on. How many number of digits you have, then you can actually make it over there. What is the pin configuration and what are the dimensions of this one? I will share it at the, I have been trying to find them out from the web, but it's an obsolete actually. I can't find it out. If any one of you can find it out, it's good for you. Otherwise I'm sharing the data sheet, the pictures over here. Yes, Abdullah, your name has 9 over there, so you will require 9 drivers over there. And I'm not putting any limitation on the size. This is very important. I'm not putting any limitation on the size over here. So if you can see over here what alphabet were there, if you can, if your alphabet is something like this size, try to remain something in this much size over there. I'm not giving any size restriction over here, but it has to be 2 layer. You can see this is a 2 layer over there. It doesn't have any transistors. It's a little different one over there. So transistors are on a different PCB, so there's just connections over there, as you can see. So it's totally up to you what size dimensions you make. Okay, I'm not putting any limitation on it, but yes, smaller the better. But certainly I will be comparing a 4 digit with a 4 digit, a 6 digit with a 6 digit, and all that stuff. We will give time for this one because since I just have not given the data sheet over there of this 7 segment, also the alphanumeric, which I am holding at present in my hand at present. This is the same alphanumeric. You can see how many pins are there. There are 1 2 3 4 5 6 7 8 9 10. So there are 20 pins over there. And how many are there segments? There are 16 segments. So 16 plus 1 dot 17, and then the remaining 3 will be the power entry points or the common anode point. Please remember, this is common anode, the one which I am holding at present. This is common anode over here. I will share the dimensions, which means this dimension, this dimensions, and this dimensions over here, the pins and all that. And what does it do? The only thing which you have to do, you have to make the footprint yourself and use that footprint to actually make a PCB, and you have to use that PCB in such a way that your common anode configuration is like this over here. Gee, any questions with this over here up till now? If anyone has any questions, please write down over there. I will upload them with Sir Bilal on Sir Bilal website, and I will also upload them on my website by today evening. If any one of you can find out the data sheet of the model which I have shared over there, Track width beta, just try to remain as small. I'm not giving any limit over there, but try to have 0.5 or 0.6 mm. Less than that, actually, it will be difficult to actually make it. And meanwhile, if you, all of you will actually make this PCB, you can actually then have this PCB at your home or maybe at your entrance of your room or something, and you can display anything, maybe your name or anything or whatever. Even if you want to display any name or any word over there, you can actually use it. Okay, so meanwhile, if any one of you can find out the data sheet of this LED Tech LA1221-21B, please share with me also. Otherwise, if you will not be able to find it, then certainly I will make the data sheet myself and share with it on the same website, ep.ng.com.pk, or with Sir Bilal's website. Yes, we can solder it. Now, one thing very important over here, let me just on the camera again over here for those who can actually see this one. I will just take off one of these ones over here just for you. Let me just take this off. Okay, in fact, let me. Okay, now over here, if you can see over here, I have soldered it from the bottom side also, and I have soldered it from the inside also. I don't know how many of you can actually see it, but soldering it from this side, it's a little difficult. As you can see, I don't know how many of you can actually see this one soldering in the camera viewfinder, but you can see that it is soldered over here. Therefore, everyone can see it's a little difficult to solder, but using a female header, it's a costly item. Female header, I don't know how many of you have used or purchased up till now, but it's a costly item. But the advantage it gives us that it can be soldered from the top side also, and it's a little difficult over here to solder it. As you can see, putting a soldering iron at that point, you can melt the plastic and all that stuff, but otherwise from the bottom it can be soldered down very easily. But at the other side, it's little difficult, but it can be done. Not that difficult over there. You can see the blobs over there very easily. It can be done. It requires some practice, but the female headers can be soldered from the top side and from the bottom side also over here. So it's totally up to you what you want to actually use over there. So if you want to miniaturize your PCB, then you have to do it. So this is just a multiplexing circuit, just like the same one. I will just share the the alphanumeric 16-digit this one, which I am holding at present in my hand over here for you. So when I will be giving you this one, so you are actually going to have this 7-segment, the alphanumeric display design, and then afterwards you are going to make a PCB of your own over here. Any questions, Ji? Meanwhile, I can just download. Any questions, please write down over there. Meanwhile, I will just see how many of people have actually please, I asked for PCB library file. I did not ask for the PCB doc file. Okay, the first one which actually came, let me just find it out. The first one came from Ego, and this is RGB. Why the name is actually, why not over there? Anyway, let me just check the first one. That is by Ego, I guess, at 229, I guess, if I'm not wrong. Actually, this is the okay, this is at, oh sorry, this is at July 7. Why this is July 7? This is something else actually. Okay, this is Hassan Mohyuddin, roll number 73. You have submitted almost 1 2 3 4 5 6 times. I don't know why 6 times. All files are there. Anyway, I will just download it and we will just see what you have done just now. I will just open this one and let me just download it. I hope everyone is having a look. I will just go through 3 or 4 files over here, and okay, this is the, here is the, okay, I have this one. So I will just drag this one in my PCB LTM software, and the library opens. Okay, so what I will do just now, you have not named it beta, you have not named it over here. I will just copy this one from here and go in some PCB file, footprint file over here, which I have just done. We have just done, and I am just going to see what dimensions you have done over here. So this one was 10.16, please, and this one is 14.06, and this one is 7.62. I guess this is okay. Seems okay. The pad size is not very good, but okay, overall it's good. You have done a good work. Overall good work, beta. Hassan Muhyiddin, you have done a good work. The next one is Rana Rahman. Rana Rahman at 231. Uh, let's see what you have done. Roll number 21. I will just download your file and let's see what you have done. So ego, your file is at 234, so I hope so. Let's see. I will just take the first 4 5 files now and we will just see. We can give some credit to the first 3 ones, or it's taking a lot of time. Okay, so this is downloaded and I will just again drag this one. Okay, sorry, this is this one, and the next one. Okay, this is the common. Better you did so strong. This is NC is here, and common is this one. You just made it a little wrong. Now this is not coil 1 and coil 2, and it seems that you have made a little over here. The names are done. Okay, Bilal, please verify this out. I don't have actually the now the dimension file. This is wrong, beta. This is 8.975 and this dimension is 4.79, so certainly this is wrong. Whoever this was, roll number 21, this is wrong, I guess. Bilal, please verify. Please share in the conversation window the same picture over here. Actually this is gone a little up over there. Please someone share it again in the conversation window. Meanwhile I will download some and anything else. Mr. Kamran, roll number 183. Let's see what you have over here. Roll number 183. This is being downloaded. Let's see, so that we can compare it. Okay, roll number 183. I'm just opening this one of yours. Okay, you have made again. This seems a copy. This seems exactly a copy of the previous file. This seems an exact copy of the previous file. You have done an exact copy. This seems an exact copy, beta. Roll number 21 and roll number 183. You are going to be penalized on this one. This seems an exact copy. You can see how the hell this is possible, that common and common, they are exactly at the same point, same coordinates. Bilal, please note down their roll number 21 and roll number 183. They will be penalized for this thing. You have given approximately with just 1 minute difference, and the rest is thing. Ego, roll number 124. First time I'm actually, I don't know what your name is actually still. I just remember your name over here. Let me just download it again. Bilal, please note down these two roll numbers, roll number 21 and roll number 183, and do share with me if they have any other past record of cheating before this also. Okay. Actually, what you have shared, beta, roll number 124, you have shared a block connector. This is not the exact library. This is a block connector. A relay was asked to you, so this is again not right. Let's go on. There's only one submission up till now. I have to just verify the submissions also, the dimensions, sorry. Roll number 69, Yazan Hussain. This is also one of some good students. I have seen his PCBs. They have been good design. And let's see what he has done. Roll number 69. Okay, so roll number 69. This one seems also a copy. This one also seems a copy. If you have shared it before with someone, okay, let me just. How the hell you can have the same COM, NC and NO at the exact same point? This is not practically possible. The three are exactly the same. Yusnan, I was not expecting, at least from this you. Bilal, please note down these roll numbers: 69, 21 and 183. Roll number 103, I don't know who is this is, Annan, Danans. Please use your own names, because otherwise at the end, when I will be actually formulating the result of this lab, this will be difficult for me to actually give it. Okay, 103, let's see what you have done. Okay, this one seems, let's see what you have done. Let's just copy this. I actually have this habit of copying this one in the PCB doc file. The dimensions are also different, you can see, but they are not the same as the, no, either you have not done it right, or either the first one has not done it right. Please verify. Bilal, have you shared the same dimension chart over here again? I asked for the dimension chart again. Okay, let's do. I'll just compare it afterward myself. Roll number, I don't know, this is 73, Hassan Muyuddin. Okay, yes, you have been sharing that. You're actually being. Let's just see who has done this. Roll number 73. Okay, roll number 73. Okay, this seems a bit nice effort, and okay, this one seems a little okay, I guess. Seems okay. This one, Hassan Mayuddin, yes, this one seems okay. The dimensions are okay as well. So Hassan Mayuddin, you may be the second one. Zishan, you have submitted two files. I don't know which one is the correct one. Anyway, I'm taking the latest one now. You have submitted two files. Mohammad Zishan. So Mohammad Zishan. Okay, roll number 63. I have it here now. Roll number 63. Okay. This one also seems okay. You have not named it, beta. You have not named it over here. It's a little mismatch, I think so. It's a little mismatch. The dimensions are not correct over here. This one seems a little mismatch. The track, this pad is not at the exact position. Anyway, up till now, just two PCBs have been there. Ahmed Khan, you have submitted how many times? 1, 2, 3, 4, 5, 6, 7, 8. 8 times you have submitted file. Wow, there has to be a limit on this one. I'm taking the last one. Okay, ji? You have submitted 8 times the same file. Roll number 31. Up till now, just two files have been on the accurate side. Okay, roll number 31. Okay. No one has written the arc symbol or any common points or whatever. You have not done anything. You just have tried to actually. This one seems a little off also. I'm just comparing with the first one. So every time this is, the dimensions are okay. Okay, let me just find out the file which I have shared before, since no one is sharing with me. Let me just, those I have just caught them cheating, or they have just recorded it, and you will be penalized on this one. I'm actually trying to find out that file. same file I have actually I just took it from the internet and I did not copy it. Yes. Okay, the dimension is 10.16 and 7.62. So let's just check. This is 10.16 and this one is 7.62. Let me just do. This one has to be. This one is a little 7.62 is this dimension. So let me just check. Is this 7.62? Okay, not exactly 7.62. This is 7.61. And this one seems close. This one seems close. These three are the exact copy, so I don't need to even see them over here. Ahmed Khan was a little over here. Abdullah Senpai, one good PCBs. I have seen him. Roll number 62. I'm just seeing this one. This is the last one. Afterwards, I will see it afterwards myself. This is just during the class just now. Roll number 62. Okay. Today I have opened so many files over here. So this one seems also a little smaller than the required one. Yes, this is certainly smaller. Okay, but I should not paste it here. So okay, this is wrong beta. This is 10.16 and you have made it wrong. This has to be 10.16. So up till now only one person has given it the right one, Abdullah Hassan. Let me just take this one more. This you have submitted beta PCB doc file. I have not asked for PCB doc file. I have asked for PCB library file. Please anyway, if you have done something, let me just check it. If you have done something. This is a big file actually. PCB library files are very, very small. They don't have anything. So this is that. Okay, this is 10.16. Okay, this is again wrong beta. Again wrong, because that dimension is 10.16 from this dimension. Okay, and sorry, and that dimension is 8. Okay, sorry, I've done something wrong. So this has to be 10 point. It's still not 10.16. It's a little wrong over here again. Anyway, those who have submitted me the wrong file or they have copied it, will do something for them. Okay, Ego, you are saying that the PCB file containing also has the block connector. Okay, let's just see. 124, you are saying it has the block connector. I can't see anything. I can't see anything better. It is just the block connector. You can see I am zooming in and zooming out, and there is just the block connector. There is no file over there. The 3 roll numbers I just gave it. I guess I gave it to Sir Bilal. Sir Bilal will actually have a look at them yourself. We will have it afterwards. There have been quite many students who have submitted over here. We'll have a look at afterwards. But these 3 students, roll number 21, 183, and I guess 124. It seems not 124. Sorry, the other one. These 3 ones. This one, and this one. They were actually a copy. Please avoid this copying thing. This is not good. You actually were striving for some bonus marks, and now you have been caught red-handed, because these 3 files are exactly the same copy over here. Exactly the same copy. There is no way that every time you're all going to have NC here, COM here, and NO here. These 3 files are exactly copy, and I'm going to penalize these 3 ones. Well, please note down these roll numbers. These are very important. Meanwhile, we will go through this one. We will announce who are the 3 winners. I know the one winner. I actually approximately that was the, I guess, the Rana Rahman. I guess roll number 21 seems a winner. I can't confirm it at present. Any questions meanwhile? Yes, I know, Abdullah Sabu. The two distance between two pads is not 10.16. I know this is different. My mistake over here. We'll do it. Over there. Eco, I can't. I don't know why your file is not opening. Your PCB connector file is always happening. I'm just opening it, and every time it's a PCB connector. Maybe you have renamed it, and something problem has been occurred on your end. G, any questions apart from the assignment is concerned? Please. Ask any questions as far as the assignment is concerned. I will share the data sheet of this LED Tech LA1221-21B, and then all of you can, we will give a 2-day relaxation for this assignment. This is the last assignment, and 2-day relaxation if it is due on Monday 12 p.m. Since that will be the Eid third day, so we are giving a 2-day relaxation, so most probably on Wednesday 12 a.m. at night, that will be the last date of submission. Okay, this is going to be the last assignment from LTM, and meanwhile in today or maybe by tomorrow we will give you the link, which will be on first come first serve basis, and you are going to select that from the project. And meanwhile next week we will have 2 sessions, and in those 2 sessions we will have the discussion of the projects. The date, beta, you can go through the date. Next Wednesday is 5th. Okay, the 5th of August at 12 midnight is the last date of submission of this assignment. Okay, I will share the data sheet by today evening or today night, and also Bilal website and also my website. Actually I can't find the data sheet online, maybe, so I have to make it data sheet. So we'll go through that one. So next week, please do not miss it. We will be discussing projects, and whoever will select whatever project, so it's on first come first serve basis. I don't know, beta, if roll number 73 is Rizan can't copy file. I don't know, beta. I am only seeing the results at present. I can't make a decision based on whatever you have done previously or whatever. We'll just have a look at it afterwards. I will ask Arsalan to actually have a look at it. All these files, whoever has copied it, these 3 roll numbers. But actually, I'm seeing it. First file time will tell who has copied it. Don't worry. Okay. अगर उस पास copy भी हुई है, if it has been copied, this actually means कि Yazan or whoever was the first one, he gave it to them, either by email or whatever, WhatsApp or whatever. We don't know about it. But these 3 roll numbers, we will make them a punishment example, because this is very important, because this has to be done. Okay, don't worry on that one. So जिससे फाइल कॉपी की गई है, जिसकी फाइल कॉपी की गई है, दोनों को ही सज़ा मिलेगी. सो इट्स नॉट जस्ट गोइंग टू बी कि जिसने कॉपी किया, आपने दी है तो वो फाइल कॉपी हुई है ना, ऐसे तो नहीं हो सकता. यू आर वर्किंग ऑन योर लैपटॉप और whatever. We I have this habit of giving these incentives and these bonus questions. You can ask the students in 3rd year, final year, or even 2nd year now. I normally give this bonus questions or something like this as an incentive so that students can work. But if you are using that opportunity also in the copying or whatever, then sorry to say, then you should be penalized and you should be made mark for that punishment. Okay. So this is all. Any questions, please write down in the conversation window regarding the assignment or regarding whatever. Meanwhile, some results I will upload today. I have made some other assignments. Actually, finding time for all the assignments, checking is a little difficult, because I have to compare one with all other files as well. I'm just going to take the attendance now. So if anyone has any issues, please, I've stopped the screen sharing it now, and I'm taking the attendance now. So please, whoever has been present, don't worry, we will change it, beta. We will change it to roll number 42. We will change it to 5th August. Don't worry. Sir Bilal will change it. No. You have to place, beta. The resistors have to be placed. The same schema, the same schematic has to be done. All the same pins over there, which means that you are going to have all the A1, A2 pins joined together, and they will be going into a ULN2803 through a resistor. So same schematic that you have done previously in your RGB or yellow dot matrix, the same thing has to be followed. So nothing changed as such over here. Okay, so it's almost the same. The drivers are the same, everything is the same, but the value of resistors we will decide it when we will have a soldering. But the packaging will be going to be the same. You have to use 0805 and 1210 packaging. 1210 packaging is for the resistor with the ULN2803 and the resistor that is connected with the emitter of your transistor. Ji beta, what is one more thing? Roll number 73. Ask. Meanwhile, I will start uploading this video on the YouTube channel for those who are still lagging behind and they had some quality issues. I'm just stopping this video.